There we go. Now we're live for the YouTube people. Okay, so today, last time we were just kind of getting going on inheritance and composition. We finished inheritance, but we kind of started to introduce the concept of composition. Yep, we had this example of code. So I kind of went over what the difference is of the case when you use inheritance versus composition. But really today what I wanted to do is show you code with composition. Well, you've seen a lot of code with inheritance, but we'll maybe a little more. And then from there, I want to show you the example of how the protected variables on Visual Code, like how that actually gets to play around when you're dealing with inheritance and composition. And then I want to briefly touch on statics. Now, you all know how to use a static variable, hopefully from like 135, like in a function. But you might know how it works in a class. So I want to just make sure I go over that. And so today, hopefully we can just wrap up completely all of the class stuff so that next time we can start talking about dynamic memory allocation, which is a big thing that I keep mentioning it because it comes in useful. And we'll revisit classes and all that stuff, but I kind of want to just get there already so that we can get going on some fun things, okay? So that's the plan. So to refresh, let me give you, let's just jump in on code this time. I want to just code today. Really, that's really the big thing, because I think code is what you want to have as reference when you're doing these assignments and just to kind of learn. So here we have code that we did for the diamond problem. As you can see, this is your inheritance. When you're doing multiple inheritance, you want to specify for each of the things that you're inheriting, each of the classes, whether that is a public, private, or protected inheritance, right? So make sure you do that for both. That's a common issue that people tend to make, is that they just put like public dad, comma mom, and they assume that the word public affects both dad and mom. It does not. You have to put it for every single one. And that is because that way you have the flexibility of being able to set each of them to however you want it to be. And if you don't put anything, then it defaults to being private. Okay, that's the other thing you have to remember. Same thing up here. I put the word public here, but if I don't put anything, it defaults to private. The only difference between a struct and a class is that the default is going to be to private in a class and public to a struct, at least in C++. Okay? So let us take all this code. I think I already copied this and backed it up. Let me triple check that actually. So today I will be updating the file that contains all these codes. Okay. So I want to open it with VS Code because that will mess up other things. But it's making me do it. Oh, here we go. Okay, thank you. So we do have that, which is 66 lines. Yep, okay, cool. So I can delete this then. Well, actually, let's leave that in there. They're using the namespace stuff, so I'll type it again. And then return 0. Okay. But yeah, so I will be uploading these to the same location as the other ones. Again, it looks the same to you. Like you don't get a notification probably that it gets updated, but it does get updated. And I tend to do that pretty much as soon as the class ends. But if not, at least by the end of today. So yeah, if you ever not find it, just let us know. Okay, so let's go ahead and do. I was thinking of doing the Tamagotchi and adding composition to that. But that might take a long time, so I'm not sure if I will do that. I'd rather do some shorter examples to do more of them, but we'll see. Okay, so I do have it open in here, so in case I change my mind. So let us go ahead and do a class. And again, this is literally an example that I'm trying to come up with right now because, I have videos from previous semesters that I've done 202, which are available for you to watch. So I don't want to do the same examples as before because then you have more examples that you can see. So I'm trying to come up with something random right now. But if you have any ideas, you can always throw them in. But for now, I think I'm going to go ahead and do something space related because there was just a launch that just happened like in the past 20 minutes. So let us go ahead and make a rocket, okay? And we are going to create a class called rocket, and this class rocket is going to contain two variables, okay? It's going to contain thrust to weight ratio, which actually should be float or double, and then it's going to contain how much fuel it has, okay? So let us say long int for that, and it's going to be called liquid oxygen, and then whatever the fuel is. So I don't know, kerosene. Okay, maybe we do this lowercase. So, you know, rockets, the way they work is you have an oxidizer and you have a fuel. You put them together and you burn things, and that's what creates thrust, right? And then the thrust to weight ratio is how much thrust you make and compare to how much the rocket weighs, which you want it to be over 1, otherwise the rocket doesn't go anywhere. Okay? So, yeah, we got those 3 variables. Cool. All right. So obviously, you know, this has no inheritance or anything, so we'll get there yet. So let us say, you know, again, when you think about inheritance and composition, with inheritance, you think that something, you know, when you try to decide what you want to do, like you want to do inheritance or composition to something, you think about whether it is a relationship or it has a relationship. So if the rocket has something, then you probably want to add that in as a composition item. If it's something that it is, then you want to add that in as a inheritance, okay? So I'm thinking for inheritance, we're going to inherit this class and make it into a different kind of rocket. But for composition, let's go ahead and add some things. And the one thing that I can think of is, like, let's make a rocket that can carry humans. So let's make a class called human, and then let's put that in a rocket, okay? So we're gonna put it up here because we want to put that into the rocket. So we're gonna call this human class. And the human class is going to contain some basic things about our humans. So I'm thinking maybe like a name for the human, an age. I don't want to go too far and make this too long, so I think maybe instead of age, this is something interesting like a role. Okay. I could use an enum for this, but no, I'll use a string. What other things could I use that like might be different? You know, just so you can see the example of. Maybe we can make a vector of it so that you can see a string of like a vector of strings that contains if it has more than one row. Why not? Okay, this gives me an excuse to use a vector. So we have to include vector for that, I believe, and then vector string roles. So what I'm saying is that this vector is going, so each human can have more than one role associated to them, okay? A list of roles, basically. In fact, I call this role, we could call this role list, but I'll just say roles to make it short. Of course, we want to have some sort of constructors for these things. So let's go ahead and make one. And also, you know, again, you would ideally make it a private class, make accessors and mutators. So like get name, set name, and then in set name, you can make sure that they set up a name that's valid, you know, whatever that means. In roles, you might want to have that one. Maybe we'll make a function for to insert a role where it just appends it and things like that. But for now, I'm going to make it public just to make my life easy, to not have to code all those functions and make the code be like massive. Okay? But I am going to create at least a function to set the roles. So like add role, basically. And that function is going to take a string, which is a role to add. And then the function, in fact, actually, you know, let's do nice coding. So let's throw that outside the class and say human, so void add role, void human add role, string role, and then all we do is append. So that would be a roles dot append, or what's dot insert? Okay, insert I guess is the one. SSD vector string constant. Insertion initialize. Is it? No. What's the append function? Isn't the code just append or add? Let's just try and see if that one will work. Maybe I'm thinking of Python. Maybe these just insert. Okay, fine. We'll do insert. Pushback. You're right. Thank you. You're right. Ah, yeah. That's the one I wanted. Pushback. Well done. Thanks. Okay. So yes, that's the one I want. Okay. So great. That is going to be thing. And you know, one of the things that we can do if is we could do a check here and make sure that like if R is not equal to empty or something, you know, we could do some quick check just to represent what you would do in these kind of functions would be to clean your input. You know, we want to make sure we're not inserting like emptiness into it. But of course, you could do more checks like that. Like you have a list of legit roles. Like you could have an array somewhere. Actually, you know, we'll add a static array like that. We'll add a static array later on maybe that will be a list of legitimate roles. And so you want to check to make sure that one of the role that you're being assigned is actually from a valid list of roles. So maybe we'll do that, maybe. Okay? But anyways, so here we go. We got a little function in there just to show you, you know, we got something decent. Last thing again, as I said, is a constructor. Human. And then this time, you know, you don't have to have, you know, we're sort of used to thinking that you have to have a default constructor without any parameters that initializes it. But like, you don't have to have one. If you create a custom constructor and you don't and it has parameters in it, like name man, and then well, there's not really any need for inserting any roles initially. So if I just say n like that, then it will never allow you to create a human class without passing this constructor. So you cannot do in main something like human age because there's no default constructor anymore. The moment you create a constructor, you sort of throw away the default one. So if you do want to have a default one in addition to that, then you have to write it. You have to do something like human, like that. But if you don't do that, it's gone forever. So in this case, I actually want it to be gone forever because maybe I want to be able to not to require somebody that if they're going to create a human that that they have to give it a name. It cannot be a nameless human or something. Okay. So yeah, this shouldn't be named though. This should be string. I'm thinking way too OOP now. Okay. So for the you know, we'll just say something like name gets n, and then for the roles, there isn't really that we need to do to that. It's already initialized for us. So I think this will be good. I am going to write a cout statement here saying human created because that might come in useful later when we're debugging or something. Or more for me to demonstrate stuff. Okay. So yeah. So the point is that now I have a human class, a nicely functional human class, and I could, of course. I don't like doing this in class because it just becomes a mess, but I could, especially for the debugger setup, but I could put this in a separate file and call it like human header file, and then I will be putting this in the header file, and then in the human.cpp file, I will be putting this in there, okay? Along with like some includes to control that, but yeah, I'm not a fan of that. Yeah, so anyways, the point is that now I can actually create I can add humans into my rocket. And that is a good example of composition because you don't want to inherit human in the rocket. The rocket is not a human. Like the human is not transcending into like some alternate universe that the rockets become humans or vice versa. No, we're just putting a human in a rocket. Or we could put a couple of them. In fact, let's put like today's rocket has 4 of them. So maybe we just make 4 of them. So how do we do that? Very easy. It's just going to be a variable. So again, for ease of access for now, we're just going to make everything public. And we're just going to, throw it in at the bottom. So there's a couple of ways that you can do this. If you want to make an individual one, so you just want to make one human, you could say human and then like pilot or something. However, this would compile if you had a default constructor. But in this case, there's no default constructor, so it probably would yell at you. So you're going to have to pass it in something as a parameter because you might get yelled at otherwise. In fact, let's just test that. Actually, will you get yelled at? Let's see. You don't get yelled at yet because you don't make an object. But if I make an object here of rocket, let's call it Falcon 9, then I think I'll get yelled at then. We'll see. Yep, now I got yelled at. So it's interesting. You don't get yelled at initially because it doesn't actually do the linking yet until you make the object. But if we look at the error here, again, I prefer the errors in the terminal, which is just weird to say. You can see that it says here, use the deleted function. That's weird. That's a weird one. This one, okay. So, no matching function call to human. Candidates are human string. So what it's saying is that in the human class, it has to call a constructor. When you create an object, it has to call a constructor. If you don't have a constructor in your class, the default one exists with no parameters. But because we added a non-default constructor, it gets rid of the default one given by us. So unless we go back in and add that in manually by typing in without parameters, then it doesn't exist. And so now it's yelling us and saying like, no. You have to have a parameter there because it's forcing it. And this is good because maybe that's what we want. We want to force people to have a name in our world here. Okay? As for this first one, I don't know what that error is. That looks very scary though. Maybe it's just a part of side effect of this. So for now, let's just I guess we're kind of forced to give it a name, which is weird. So Kyle's name is Timmy, I guess. Okay. Now, why am I still getting? Why am I getting like 50 different underscore linings? Identifier by string constant. Is it called human class? Yes. Human pilot to me. It is not liking me doing this, it seems. Expected a type human. It does not like this at all. If we were using a pointer, we could solve that issue. I'm not sure how to get around that easily. Unless I add a default constructor, which I could and work around that. I'm just trying to see if there's ways without adding the default constructor that I can get around doing this. Let's just make a... No, there's something I can add in there. No, there isn't. There's no clean way. So I'll have to add a default constructor up here. Which means that we will be able to have humans without names. But I guess that's okay. When we learn about, I mean, there is one way to get around this, by the way. But that's what we'll talk about next week, which is dynamic memory allocation. Because what I could do, and would actually make more sense for this, is to make this a pointer to a pilot. And then we make the pilot somewhere else. But we haven't learned about pointers yet. So for today, we're going to have a default constructor with a nameless human. Otherwise, it will not. This just will not work. So yeah, I guess for the nameless human, we're going to say none for the name. I guess just to get around that issue. And maybe we'll revisit this example next week after we learn pointers, and see how we can how we could have fixed this otherwise. Why is it oh, I forgot to call it this one. There we go. Okay, so now we don't need to do this part here. It's just gonna make a pilot without a name, but we'll have to assign that manually. In fact, we could do that in our constructor here if we really want to. But so we could say something like pilot name gets so Jane instead of Timmy now. Timmy failed us. He couldn't get it working. So all right. Also for the rocket, I could do a custom constructor. Too much effort. We are just going to manually set some values. So we're going to say trust to weight ratio at launch of 1.5, and then the amount of liquid oxygen, you know, what are some realistic numbers for that? Let's see, Falcon 9 capacity. Oh, RP1, that's the name of this. So we could do this RP1 instead of kerosene. Which I believe is like a variation maybe of that. Propellant. If it takes more than 1 minute to find this, I'm just gonna give up. It's okay, here we go. Okay, so we're gonna have to pick a dimension for this, so we're gonna use kilograms for this, just because I mean we use pounds too, but we'll use kilograms. That seems more legit for space. So this is supposed to be 22,800 kilograms for the liquid oxygen, and then for the RP1 fuel, oh wait, no, what am I doing? That's the payload amount, that's not the liquid oxygen. The payload is how much it can get to space. Yeah, I was like, that's really light. Okay, here we go. So it's 39, so this is gonna be in gallons now. Okay, that's fine. 39,000 gallons of cryogenic liquid oxygen, and then we have 25,000 gallons of kerosene. Okay? Which is that RP1. That's actually, I guess we didn't need to make them longs. So let's get rid of that. Okay? Why is that underlined? What did you like about that? RP1, TWR. And let's just see what it complains about. See, this VS code is buggy now. There's nothing wrong with the code, but it underlined it. It wasn't like refreshing the what do they call it? The linter. Okay, so we got a little rocket, and we have a human in it. And this human is literally an example of composition, because a rocket has a human, okay? Versus like a rocket is a human. If we want to add a couple of other humans, we can add a little vector in here of the human class and call crew. In fact, I'm going to get rid of the pilot here for now, because that way I don't have to hard code a name for him or her, and then just call this the crew. Okay? Because now in here I can go ahead and pass that in. So maybe I can be like oh, you know, this might be a good example to show you a default parameters versus non-default parameters, right? Assuming that I remember myself how to do that. And also can do that in constructors. I don't quite 100% remember if you can do it in constructors or not. It might be a limitation that you won't allow it, but we can try. So for example, what I'm talking about is that, like, suppose that you know we can keep up to 4 crew in the vector, right? So you know we can say something like they're all strings. We got string crew 1, string for crew member 2, crew member 3, and crew member 4. So you know we can say that if nobody passes that, then we'll say this is the pilot. And then the second one's going to be the co-pilot, I guess. Well, flight. I don't know what the official names are. Let's just call him co-pilot. Whatever. I don't know. This is like the medical officer. And the fourth one is like the science officer or something. Just uppercase that. So this is called default parameters. So that means that if you don't pass in any value for these parameters, they will be default to that. It's going to be useful for making your code more robust and flexible. But in the constructor, what I want to do is basically add those in. So, you know, I can basically say crew.pushback. Thank you for reminding me about that. C1, and then do the same thing for all of them. Crew member 2, crew member 3, and crew member 4. No, what am I doing? That's not going to work. That is not going to work because those are strings. So we need to actually push back the human. So let's just say, let's add a little set of parentheses where I say human, like that. Okay, so that's going to make an object called human. So all I got to pass in to the rocket is the name of the crew, and then this will kind of set it up. Although that's going to put them as, that's going to be using this name to give them the name. So that's not going to be the, that's not going to be the role. That's going to screw up some things unless we pass in 2 sets of values. Because right now that's going to initialize the name of them unless I change it here and make this, instead of going into name, to go into a role. So yeah, let's get rid of that. I don't like that. We'll just do that manually. In fact, we'll make a function that does it so that we can avoid this mess. Okay? We'll make a function here called add passenger or add crew. Okay? So that function, this will take already a human that, well, we could either take a human or we could build it. So let's actually build it. So we'll take a string for the name and a string for the role, and we'll go, well, we could pass in more than one role at once, but yeah, you know, it's a good practice for you to remember how to pass arrays. So we'll make this be an array of roles. Okay? Why don't you like that? Okay, that's why. I'm thinking like Java or something. Okay. There we go. So what the function will do is it will go ahead and push back into the crew. And as we push back, we will create the object. So we'll say human, and then we'll pass in the name. And then once we do that, we need to insert the role. So what we can do here is we can modify the constructor, passing the second parameter, which is role. So then here we can say roles.pushback R for the role, and that will update the role when we create it. Okay, so human n comma R, like that. I think that should be good to go. It's underlining it, but I don't trust that anymore. So now we probably just have to add some semicolons and other things. No results found. Wow, that's weird. Okay, let's try that here. No matching function call for string and string. Human and R. Oh, it's because we did an array. That's right. I forgot about that, being an array. So for that just makes it more painful for us to do. How do we get the array in there? We could do a loop where we just update the value every time. So yeah, okay. So then in that case, we can get rid of this, go back to how we had it before, and we can use the function add role, which is why we created that function. Forgot about that. So create the human first with just a name. And then, now that we created the human, we can call add role on that human. So to get the last item from a vector without deleting it, you know, we could do it that way, but I'm gonna make my life easy by just making the human locally first, like human temp, giving him a name, doing all I gotta do to the human, and then finally throwing him in here. And that will save us a bunch of headaches. Okay? So it's a good idea when you're creating objects that you need to insert somewhere else. Create them locally first, modify them, all you gotta do to them, and then call the insert function that you might have. Okay? So in this case, we're gonna do temp.addRole, and then we're gonna put this in the for loop for, you know, it's just a normal array, so we can't do like auto. We can say int I is equal to 0. I is less than, oh, we need a size is it an array or is it a vector though? Let me check that. Oh, well, it can be whatever we want it to be because we haven't defined it anywhere. So to make my life easy, I'm going to make it a vector because then I don't need to pass, otherwise I need to pass in like a third variable that's the size, which is too much work. So I'm just going to make it a vector of strings that gets passed in for the roles. Okay? And if I do that, oh, I gotta get rid of this word string in here. Then I no longer need to do this for loop like this, and I can actually use the range-based for loop for auto I and R. Then I can say temp add role I. Okay? So what that's going to do is iterate through this array that I pass in and pass in all the roles for me. Okay? I don't like how that is not. Oh, it's probably because of semicolon here. Let's see if this is good to go now. There we go. It compiled. So it must be good. All right. Okay? So what I've done is I have this add crew function that's part of the rocket. So it is able to add the crew. So this is a good usage of composition because not only am I including an object from a different class in here. In fact, I'm including a list of them. But also, I'm enhancing the usage of that object with a function called addCrew that handles that object and does things to it along to having things in my class. So again, with inheritance, you would inherit some stuff and you can modify and update it and whatnot, but it's kind of mixed up with everything else. Here, it's nicely contained. Everything related to the human is inside an object that is of a human type. And then I can make functions local to my class, make them public, private, protected, or whatever, that can modify that object, can enhance its capabilities, but it's still nicely contained, so it's not mixed up with the other stuff. So that's the big power of composition and why it's really good to use in a case like this. So, finally, let's just test to make sure this works. So when we make a rocket, let's go ahead and add crew to my rocket. So Falcon.add crew, you can see that that is very nice code. Like, it's self-documenting that what this line of code is doing is adding crew to a rocket. That's because they have a good naming convention for variables, or in this case functions, and just the order of things, okay? So I'm passing in a string that is supposed to be the name of the crew member. So Jane, and then a vector of roles that I wanted to have. So for that one, let's just make it up here to make it not such a massive function. So vector string roles, and then roles that append. Oh, sorry, pushback. I'm thinking Python list. Pilot. Okay. So I just pass in here roles, and this should be good to go. Okay. Just to do one more function here, I would like to have a nicer version of this rocket that prints out the list of passengers in the rocket. Okay? Maybe that, and also it has some extra features. So maybe we do inheritance for that, because that is a rocket that's just modified, upgraded. So let us make a class called, rocket. I was gonna say rocket V2, but that's people will think that's like the German rocket. So let's just call it super heavy, or yeah, Starship. Yeah, that's cool. Okay, and so let's inherit publicly, as you most likely will do all the time, from my rocket. And what we want to add, as I said, is the capability to print out the contents of the other rocket. So first of all, there's, right now it's public, but if like the crew thing here was private, which I could make right now, that would cause issues accessing those contents from the derived class, right? Again, that's what I mean when I'm talking about protected variables, that this causes problems. So you would want to make this protected. So now, public can't access it directly, but you can access it in the derived class. So, which is what I'm going to want to do, because I want to make a function called print crew that is going to print out the crew members. Okay? So let us make that class. Let's make that function. So I'm going to call it Starship print crew. Don't forget the return type first. And that's just going to be a simple loop. And the crew happens to be a vector, right? So we can just use the range-based one. So auto C of crew, C for crew. And we can just make this pretty and say print, not in Python, current crew. All right, and mine there. And then we're going to print out something like the name. So C dot name. And then we're going to print out the roles, which can be its own for loop, actually. So let's make another for loop. And C dot roles. And I like this, actually. I like the fact that we have these nested loops inside of each other and stuff inside, because it's a good example of things like that. Okay? So, well, that's really random. I've never seen that before. Gifting this up. That's cool. So is that random? I wonder, like, what if the person is like not even a student? That would be very sad. But yeah. So, cool. I'm gonna have to do a competition at some point to like award you guys something and use like the funds, because I don't know, it feels weird keeping the funds. So we'll probably do a competition at some point and they'll have a reward or something. So yeah, but yeah, so we got auto roles, and so here we can go ahead and print out like the roles. So you'll see out R, I guess, for role. And no, I'm not going to put an end line here, because in theory, that way they can all be nicely separated. I'll put a comma. And then after the loop, I'll put an end line. But we are going to have to add we need to make something that has like more than one role. So maybe we'll do like a pilot comma something, or we'll see. Okay? So yeah, I mean, I could add a lot more things to this. Like I could just throw a random variable in here. Like what could be something that we could throw in here? I don't know. I'm gonna do some time stuff, but here, we'll just do number of flights for an integer. Number of flights. And that could be something like the number of flights that the rocket has had. So every time it flies, it increases by 1 because it's a reusable rocket or something, okay? I mean, the point is that you can do whatever you want. Like you can add functions, you can add variables, etc., okay? So yeah, as long as you do all this, you should be good to go. Obviously, there's probably bugs in my code, but we'll see. Let's just kind of go with the fact that it might be okay. So let's make another rocket. This time we're going to call it Sn20. So it is a Starship Sn20, and there's no constructor, so we just kind of have to add things manually. So let's throw in the same pilot. We already have that variable, so let's just throw it in. So sn20.add_crew, we cloned her, and then we said it's called Jane and Rose, like that. And also maybe let's go ahead and add another crew in there. This time let's make one that has multiple roles. So let's just take our current roles thing. Well, let's make another one. So vector string roles2. Probably a better way of coding this to not have to make these vectors ahead of time, but that's okay. Roles are pushed back. So science officer. Wait. Yes, but we haven't picked the name yet. Science officer, and then maybe we make the other role other than science officer is like communications specialist or something, and then last role is radio operator or something. I don't know. I'm making this up as I go. Okay, so when we finally go ahead and add in, this person's gonna be I don't know. Let's do Kyomin B, since that's the person. Yeah. Okay. So that's the roles, and then roles 2. Okay. So we'll see what happens. We'll see if your rocket makes it. If it compiles and it doesn't crash, it makes it. But here, last thing is we want to see if the function works. So let's do print crew. And if it all goes well, we'll print out the crew pretty. If it doesn't, it'll print out nasty or just crash. We'll see. So, okay, it printed out well. So, rocket did not crash. So, let's see. So, we got human created, human created, human created. So, we have 3 humans. That's because we have one for the Falcon 9 rocket, and we have 2 for the other one, even though they're both called Jane. And, yeah, so we got current crew of the first rocket. Or, actually, this is the Starship 20. We have name, Jane, role pilot. Name, Kyomin, roles, science officer, communication specialist, radio operator. It looks good. I think we have this little comma that looks weird because of the way that we have the loop. But other than that, it actually worked out pretty well. Yeah, to get rid of this comma, I'd have to do some stuff, which I don't want to. So we'll leave it. Looks nice. Okay. So, yep. So, yeah, I mean, this is an example of composition. And you can add more things in here. Like, you can just make any classes for anything you want. Just really fast, I'm going to make random class. We're going to call this class payload. And this is just stuff that the rocket carries, which is going to have a weight associated to it. Double weight. Set it to 0. And maybe like volume. And set it to 0 as well. And there you go. Oh, by the way, you know, we've been using classes long, but you could totally make this a struct too. Like, that's okay. But I'm going to keep using the word class because you've seen enough of the word struct in 135. So, yeah, you know, that's a class. And now I can totally throw that in randomly in like the rocket. Let's do it in this one. So this one has a payload capability. So we can just make an object here and call it payload P. And I think it was upper P maybe? Yeah, upper P. So there you go. Now it's got a payload in it. And so, you know, I don't have the functions for it, but I could add them. But for now, let's just temporarily add it in. So let's just say sn20.p for payload dot volume. Let's say it can carry 100. 1,000, I mean. And then for the p dot payload dot weight, it's going to be 2,000. Okay? And there you go. And of course, we can modify the print function to print out those things and say something like cout payload. And then if you want to access them from here, that would be p dot volume. And then p dot weight and line. Of course, this won't look as nice, so we have to put some pretty text around it. Like that, and yeah, that should be okay. So right now, the payload is the default values, which was 1,000 and 2,000. Of course, I could modify them, right? Oh, there we go. Now we got a nice user for the comma, I guess. Although now it looks like it's part of the roles. So maybe we do a line feed there. So there you go. Okay, so hopefully that gives you a good example of composition and inheritance. We've seen a lot. The last thing I want to show you, at least that I really want to show you, is the static stuff, right? So first of all, let's make sure we're on the same page of just using a static variable in a class, like just a static variable. So let's just throw in something static. So one cool usage of static is to keep track of how many objects you have in your environment. Okay, and you might want to do that and set that up in the base class, because you know, if we could make different rockets. Like I could totally make another rocket right now and call it like I'm not really going to use it. I'll just make it anyways. We're going to call it class super. What's the name of the Jeff Bezos one? New Glenn, the one that will probably never fly. But yeah, New Glenn, and then you know, that's it, done. So, well, I had to inherit from something, so let's just say that it, you know, you don't have to inherit from the Starship one. We could totally inherit from rocket, so you can throw in like that, and then you just made a rocket already. Like that's it. So if you know, if you go ahead here and say something like New Glenn, you know, V or something, then you made the object. Okay. So, anyways, let us make a static one. A static variable in the base class. So in here in the rocket class, I'm going to go ahead and make a static variable that's just going to be used to keep track of how many rockets exist in the world. That's just a good usage. And so we understand static variables. The difference between a static and a non-static is that when you have a variable in the class, so for example, we have our trust to weight variable here, right? That trust to weight variable is a variable that's associated per object. Okay, so like, to give you a visual representation of that, whenever I make a rocket object, you can think of like making this little square called rocket, which contains all the different variables that we have. So like we have an int variable, I think, that was called trust to weight ratio. Then we have another variable for LOX, and then we have a variable for RP1, and so on. Okay. We also have pointers. Technically, we haven't talked about pointers, but we have references, that's a better word, to functions. Okay, and so those functions, you only keep one copy of them. So the functions like add crew, that is something that is like, you only keep one copy in code, because it would be pointless to have like thousands of copies of the same function code. But you just keep references to them. And when you call the function, you pass a reference to the location of these variables so that you can handle these versions of the variables. Okay, but anyways, forget about the functions for now, just think about the variables. When I make another object of rocket or any of the inherited classes, what I'm doing is I'm making a copy of everything, basically. More than copy, I'm just making a new version of it. So it has its own variables, okay? These variables are not shared. They're independent of each other. So LX here and LX here are completely separate variables. They may represent the same thing because they're both rockets and they're both liquid oxygen, but what I'm saying is that they're completely independent of each other, okay? They live in different places in memory, and they're not linked together. That's good. That's what we want, because we don't want to change like one rocket's like thrust to weight and that modifies all the rockets, right? Or like in Tamagotchi, if we kill one of the Tamagotchis, we don't want to kill like all the other ones, right? We just want to kill ours, I guess. It's kind of evil to say, but yeah. So ultimately, what I'm trying to say is that they are independent of each other. However, what if you wanted to have a variable that they all share together, like the parties variable or something, like something that is shared amongst together? So like, suppose that you had one variable, and in this case, we're just going to call it like an ID or whatever, or not ID, but count in this case, that everybody could access. So like if I say count here, it's accessing this guy. And if I say count here, it's accessing this guy. So they both all share the same one. Why would you want to do this? Well, again, it's just the power of being able to do it, not whether you want to use it or not. Like I said, in my personal experience, you tend to use that for something that you want to share, like a count. So like whenever you're making an object, you increase the count, and then you can use that count variable to, because it's unique, to give an ID to the object. So then you can create an ID for each object based on what the count was when the object was created. And that's a really great way to have a unique identifier for each object. So every time an object is made, the count goes up and it gives that number. So like I'm object 1, I'm object 2, I'm object 3, and none of them have like the same number. Okay, that's one usage of it. That's what I'm going to do. Other than that, like, it depends, you know. You could also use it, I suppose, as a constant. If you wanted to have a constant in your class, that could be one way of doing it. You just have to make sure it's a constant so that people can't modify it. But maybe you want them to modify it occasionally. So yeah, also efficiency-wise, if there's something that you need to have in your class and all of them have to have the same thing, a static is good because there's only one instance kept in main memory. Remember, the two green squares are separate in memory, so they both take space. They both take, if it's an integer, 4 bytes. And so right now you got 8 bytes in there. Whereas count is only going to take 4 bytes because it's just 1. Sure, you need memory to store the address of this, but just like you can have a static variable, you can have an entire static object in there. So like I could have a massive object, that's tons of memory, but I have one instance for all classes. So all I gotta save is that one big instance and then some tiny little references. So it's also from an efficiency point of view. Just remember that it's one that's shared. And if one modifies it, it modifies it for everybody. Okay? So let's go ahead and build a static. So again, for the static, I'm just gonna use a counter because I'm gonna use it to assign an ID for each ship. So the way you do it is you write the word static, and then you put the type, and then you put the name, and then you don't do anything else because you will get yelled at, not by me, but by the compiler if you try to initialize a static in a class. In fact, let's get yelled at together as a team. Bam! ISO C++ forbids in-class initialization of non-const static member rocket count. Line 27. Bad person for doing this, I guess. Okay? So, if you get yelled at, don't feel bad. Just go fix your static probably. Okay? So, the reason why, it makes sense. Like, if you sit back and ponder, like, okay, why won't it let me do that if it's a static? Well, the reason why is because static variables are independent of any object in the class. And if you allowed, each class to initialize a static, every time that you made a new object of that class, it would reset the variable. Every time it would reset it back to 0, and it would be useless. So this is actually C++ being nice to us and saying like, yo, there's a reason you don't want to do this, like trust me kind of thing. So yeah, let's trust it. Well then, how do we initialize the static? Well, not bad. You just have to do it outside the class somewhere. So like just somewhere outside the class, in the global scope or whatever, and here the syntax gets really weird and I always like forget it. So I think I had it open in the browser. Yeah. So you don't put the word static, but you have to put the type again. So it's an int, wasn't it, right? Yeah, it's an int. You put int, so and then you gotta put the class scope resolution operator in the class itself. So I guess it was rocket. Oh yeah, I don't like having like one space. And then the variable name. So that is count, and then equal to whatever you want, and then never ever change that variable inside a class unless that's what you intend to do, because it will change it for everybody. Okay, just remember that. So yeah, that's how you initialize a static. So now we run it, we don't get yelled at. Okay, I always screw this up. Like I always forget and put the word static here, or not put this part or something. So don't feel bad if you don't use it. It's because it's not something that's used often, so you just kind of forget it. But you can just Google it. In fact, let me link you to a reference on static, which I actually looked at right before class started because I wanted to make sure I didn't screw it up. That was, like, hey, let me check this, make sure I remember how to do statics. So yeah, it's just a link. I actually only browsed it for 5 seconds, but it was enough for me to remember, so maybe it'll be good for you in the future to remember as well. Okay? So let's actually do something with the static. So as I said, the static is going to increase every time that we make an object. So where do we do that? Well, we can do that in the constructor, right? Because the constructor is the one that's going to run every time an object gets made. So that's the ideal place to increase it. So, and it only gets run once, which is when the object gets made. Although, technically speaking, I think you can call a constructor at any point in time in your code, but that's just looking for trouble. So don't do that. Don't try that at home, kids, kind of thing. So let's go ahead and say, in my constructor, my count is getting plus plus, okay? So if I do that, and by the way, statics can be public, protected, or private, which is really trippy because like, if you've been listening to the lecture for the last few weeks, I've been telling you that private variables are not accessible outside of the class. The only ones that are accessible outside the class, like in main or something, is public, right? Protected and private you can't access. Protected you can access in derived classes, but not in like main or something. Well, The one exception to that is statics, actually. A private static variable is accessible outside the class. However, that one exception is only for when you initialize it. So like this line of code, you know, right now it looks okay and looks legit because it's a public variable. But even if I switch this to private, so even if I go in here and change the static int and move it to wherever I have some privates, here we can make it protected, why not? If I do that, you know, this will still compile and run just fine. Even though it's technically a protected variable, or if it was a private, it will still be okay. So statics are like the one exception to the rule. And that I'm not a fan of having exceptions to rules because it's harder to remember those exceptions. But it kind of is the only way they could get around it, because like you gotta initialize it somewhere outside of the class. So even though it's private, you can. So have fun with that. This is definitely a question. I mean, we're built, by the way, the exam is being also built by all the instructors, but this time we'll all look at them to make sure there's no questions that none of us know. And if it slips through, then we just curve it and get rid of that question. But like, if I wanted to be really evil, that would be a perfect question to ask. Like, you know, put some code and say like, is something wrong with this code? And then put this, and then put like private, and then put the word static. Because normally that would be bad code, but because the word static is there, then this is the exception. So that would be if I wanted to really be mischievous and evil. But I probably won't do that. But I would ask in the test is like how to use a static. That would be a fair question. That's not like mischievous or tricky. But you know, that would be fun too. I'm curious how many people would screw that up. Because you have to be. It would no longer be a question of if you know the stuff. It's like how careful you look at the question before you answer it, which just brings anxiety into everybody, which is not a good thing. So, anyways, but yeah, just remember that even though it's private, that is the exception, that you can access it outside just once, just to initialize it, never again. If I write another line of code we needed to change it, the compiler will be pissed at me. Like, if I do this, now it's yelling at me. And I don't know, VS Code just keeps breaking more and more. But yeah, here you say redefinition, blah. So it yells at me, okay? Well, actually it yells at me to be fair because I have the word int in there. But if I do this like this, then it will still yell at me because now it's saying I'm trying to access it again. So it's protected within this context. So it's like literally 1 second ago I accessed it and you were cool with it, and now you're not. You're not telling me it's protected. Well, yeah, because this is the one exception. So, yep. If I was to just remove this for a second, you would see that the code. What is it now? Does not name a type. What? What do you mean does not name a type? That's weird. Rocket account does not name a type. That's trippy. I don't know what that really means. What does that error mean? I don't recall seeing that error before. Oh, I see what it is. It's because it's in the global scope. So it's like it needs to be. It's because it's like not in main. But if I threw this in main, then it would be okay. That's why. So yeah, it's because it's just in the global scope. So it's just trying to tell me like you can't run the code that way. Okay, but now if I switch this back to protect it, you'll see that it will yell at me because it says it's protected. So you see protected. Okay. So yeah, that's I forgot about that. Yeah. You have to you can't write code in global scope like that. It will get really angry at you. But this might be misleading to you because it's like that. But trust me when I say that if I've had this in main, it would still yell at me. So yeah. Okay. Anyways, for now, let's keep going though. So let's go ahead and write a quick function in Rocket to just print out what the count is actually. Since I have it protected, and also just so you can see it. So print count, or I should just return count. Get count. I'll just put it in here. Return count. and make it a value returning function. So now, if I go in here all the way at the bottom and I say cout number of rockets, and then I do, oh, this is actually very interesting. So right now, if I want to call that, I just call it on any object. So I can just say like v.getCount, but I could also, just to prove to you, I'll put a space between them. I could also do Sn20.getCount, and they're all going to give me the same value. In fact, if I make it not protected, so if I make it public, and then I go in here and manually print it out by saying v.count, more spaces, or even if I do Sn20, or what was the other one called? Falcon 9. Falcon 9.count. Or I can even do it like this, like I was doing before. So I can say rocket. Hold on, sorry. Count. I could print it out like that. That would also work. I could also do Starship count. That would also work because it's public. The only one that would work if it's not public is this one, by the way. But I just want to show you the different ways you can refer to this. And then you could even do. Well, I think that's all the cases. Otherwise, I'm just repeating what I'm saying. Is there any other way that would be interesting to access it? Not really. That's it. Okay. So this should all give me the same numbers. As you can see, I get a bunch of 3s. 3, 3, 3, 3, 3, 3, 3. Okay. Let's add a line feed at the end of this though. And where does the 3 come from? Well, I went ahead and have Falcon 9 rocket. I have Starship Sn20, and then I have a new Glenn. So that's why I have 3 objects. Okay. So that, and if I keep making more of them, so if I make like another Starship, in fact, can I quickly make a bunch of them? I could make a little for loop. For I, int I is equal to 0, I is less than 20, I plus plus. And inside, I'm just going to keep making objects. Now, these objects are just going to be made and thrown away immediately after because they keep running through. But they are going to be made. So every time they get made, the count is going to increase. So you'll see now we got 23 because of that. Okay? So lastly, let's go ahead and, well, not lastly, because I do want to show you static function. But here's the... here's where this can come in useful. If I make a ID value now, call it int ID, and then in my constructor, I can set ID equal to count plus plus. What this is going to do is going to take. Remember, count plus plus is post increment, so it takes the value out of count into ID and then does the increment on count. So if count is equal to 0 right now, it copies 0 to ID, and then count becomes 1. If it was pre-increment, where I do like plus plus count, it would first increase it from 0 to 1, and then copy it over to ID. So by doing this, I'm copying the old value of count. So if I do this now, and then maybe in the, whatever, let's just access it directly. If I just access that variable directly here, because it's public, if I say cout, let's say Sn20.id, you will see that that is a unique ID of the program. Okay? So like, for example, this will have ID, where is that value? I'm assuming this is 1 here. So let me just add. That to see it better. So this is ID 1. But if I change this to be, for example, the New Glenn rocket, this has an ID of 2. If I do Falcon 9, I expect that to have probably an ID of 0 maybe? Or yeah, 0. So Falcon 9 is 0, Sn20 must be 1. Yep, it was 1. And then this is New Glenn is 2. And then these all have like, in fact, if I add a line of code in here that says SNX ID, you will see that all of them have different unique IDs. And by the way, because these are made and thrown away, like the ID number is gone. But what I'm saying is it's always unique. It's always keeping an account. It's a great way to organize your objects when you're doing something with a lot of objects. So that's just an example of a static variable. Static functions, you do the same way. So for example, let's say that in the human, I don't want to modify the rocket anymore. Well, no, because we're going to have a static value in that. You know, static functions are kind of picky because so the idea behind a static function is that it should only modify static variables, and it can even be called without being referenced on an object, okay? So for example, I guess we have to do it on the rocket because this is where we have our static. Nah, actually, we'll do it on payload. So let's say on payload, we want to make a static function. And this static function is just like some math function called add. Okay? And the static add function can take two variables, which are going to be two doubles, double 1 and 2, double A, double B, and is going to return a double. And all it does is going to be return A plus D, or B, sorry. Okay? So, not very exciting, but what I'm trying to get to with that function is that if you try to call a function here, so let me just make another, do we have a payload object somewhere? Let's just make another one. So let's just say payload test. So if I have a payload test, you know, I can do test.add and pass in two numbers and then see out the result. Semicolon. Okay, so payload test. It really bothers me when I don't put the line through there, so yeah, I need to. Okay, there we go. Payload test 3. Okay, so that is the answer to 1 plus 2. Okay, surprise there. So here's the thing. If this is any other function, such as like the get count from Sn20, or let's just do one more function here and call that function double weight squared. We'll say this function takes its weight and squares it, okay? So return weight times weight, okay? So that function's job is just to take the weight, multiply it times itself, and then return that, okay? But this is like a normal function, a non-static function. So I can call that function here, right beneath it. So we'll say test2. I can say w squared, and that's going to give me some big number. It just went to 0. Wow, did we initialize this to 0? Yeah, we did. Okay, but that's why it got me 0. But you know, if we make it 5, then we can get 25, right? So we get 25 out of that. Okay. So here's the thing. This is a normal function. This is a static function. So far, you don't really see much. Okay. But here's the catch. If I try to call this function, like if I want to say something like, let's do another test line. So in this test, what I want to try to do is I want to call this on a specific class name. So payload. If I do something like this, you'll see that this is not compiled. In fact, I'm going to compile it in the terminal to see that error. It tells me cannot call member function double payload without object. What this is saying is that this W2 function is associated to a specific object. And that is because it needs to know which object it's using, because each object has a weight, right? So like when we're looking at the payload class, it currently has two variables in there. That's the weight and the volume, right? And so when you're doing W2, whose job is to take the weight and multiply it times 2, so W times W, it needs to know which object. Like, are you talking about the test object? So then I can actually take, this value and then use that, or are you talking about some other object, right? So me just basically stating the class name without the object, it's like, I don't know what you're talking about. Which specific object do you want me to do this on? So that obviously doesn't work, okay? However, with a static function, you'll see that this will not complain, and it runs like a champ. Or it would have if I don't know why it didn't run. Function called to payload add, because add requires two numbers, right? So 5 and 1, okay? So there you go. I was like, it's disappointing if it doesn't run. So you can see that it takes 5 and 1. 5 plus 1 is 6, right? So the reason being is because the static function is not linked to anything. Now you might be like, well, that's only because you're not using any of the class variables. Yes, that's exactly why. However, the word static in there is guaranteeing to the compiler that you will never be including any class variables in the class unless those variables themselves are static. If so, that's okay, because again, those are shared. So when do you use it in real life? Well, sometimes you're making a library function and you want to have some class some functions that you can use for stuff that you just want to throw in with your library, but they don't particularly need to be used on the specific object. So that's when you could make a static. Also, if you need to do some math with static variables, like increase a static. But you could also do that with a normal function. You just need to give it a random object, like a dummy object, okay? So hopefully that makes sense. Again, it's not something you would really use often, but it's good to know, because if you ever see code like this, you might be like, whoa, they're calling this in the class name and not on an actual object. Like, what is happening here? The reason is because it's a static a static function, and you have these values which must not have any code in here inside the add function that touches any class variable unless that variable is a static. So if I go in here and say something like weight plus plus, the compiler will yell at me. There's a lot of yelling today. And say that in static member function, invalid use of member weight in static member function. So it's basically saying you can't do this. Now, if I had a static in here and call it int ID or something, and then let me initialize it so everything's okay. Payload ID equals 0. I don't like using the word ID because we use it for something else. So let's use X instead. So now if I do X++ there, that will be okay. As long as I write all the code correctly. So I keep putting a lowercase there. Okay? Because it is a static function, so it can access static variables. Okay? So a static function should only really be accessing static variables or just something that's not in the class. Whereas a normal function can access both static and non-statics. Although be careful when you're accessing static to make sure that's actually what you intend to do, because you are going to be modifying that static variable, which will be accessible by any other object, which is okay in something like this where I'm using it as a count to increase, but might not be okay if that's not what you intended. Okay? Yeah, well, good point. It wouldn't. But either way, the compiler would have yelled at me if it wasn't okay. So, like, technically speaking, yes, that code did nothing. But the compiler would still be pissed at me if it was non-static. So, yeah. But good catch on that, though. So, fair enough. So, yep, that's it. We are out of time. That actually kind of worked out because I covered everything that I wanted to. So, we did some examples of a class, like a nice beefy example of class with inheritance and composition, so that you can see some practical use of what we've been doing. I went over statics and emphasized on the whole public, protected, and private. So we are now done with classes, at least for what we can know. we're going to revisit them after we talk about dynamic memory allocation. But that will be happening next week first. So be ready. Next week is when we deal with pointers. And that's, it's not hard for me, but I think for people that are learning the first time, people claim to be hard. So we'll work it together, and hopefully you're all experts at it. So, come in with full battery next week for the pointer magic, okay? And definitely, if you have not set up a debugger, you want to do that, because with pointers, you just have to have a debugger. Otherwise, when your program crashes, it's just like, it crashed. Good luck. So, yeah. All right. So, great. Well then, thank you all for watching, and I hope that you all have a good rest of your day and weekend, since I won't see you until next week. Let me know if you have any questions, all right? Thank you all. I'll catch you next time. Take care, everybody. Have a good weekend. Rest of your week and everything. Bye.